Hello, everyone. And I was hoping that maybe we could take a week off from the chapters, but these chapters are pretty small, the last two, and I don't want to try to rush everything. So, in the midst of everything we're doing, preparing for our final paper, writing our first submission, gathering articles, and all of that, let's take a little bit of time and go over this chapter. It's, as I said, a relatively short one, so it shouldn't take all that much time. Um, Let me get into presentation mode and um, let's go over the objectives. So for this chapter, we're going to be talking about a different type of um, design called a quasi-experimental design. Of course, quasi means partially, and there are reasons for this. Remember in chapter 10, we talked about one of the ways that we sort of mitigate, and chapter 11, that we mitigate internal validity problems is by either using a matched groups design or random assignment, which is a big part of internal validity. In these types of studies and in the real world, there's a lot of times where you can't just randomly assign people into one group or the other. Sometimes there are groups, kind of like what we talked about with what we call participant variables in chapter 12, where if you're assigning one of your IVs as gender, which I actually discourage when you guys are doing in-class group assignments for your experiments, or I try to discourage participant variables as much as I can, because a lot of times you'll get an unequal amount. A couple of years ago, somebody did a study on social media use and stuff like that, and there was, like they had to change their operational definition of high and low use because most everybody in the class was on there for many hours a day. And then there was another one, like, people who use social media versus who doesn't. And that ended up being like 3 people in one group and everybody else in another. So we'll talk about that. So I'm going to explain how quasi-experimental designs or quasi-experiments can be just like a regular experiment, either a independent or between group design or a within group design within subjects. I will talk about 4 different different designs for quasi-experiment. Non-equivalent control group design, which is a between subject, interrupted time series design, and non-equivalent groups interrupted time series design. Then I will talk about whether quasi-experimental studies can avoid. We know that the selection effects is a possible problem when it comes to internal validity, but what about the other types of internal validity problems that we talked about? Is there a problem with maturation, history, regression, attrition, testing, instrumentation, observer bias, demand, and placebo effects? We will explore. Looking at design and results, I will and ask you guys to analyze whether a quasi-experimental design allows you to rule out these internal validity threats. And I will explain the trade-offs of using a quasi-experimental design, right? So if we're sacrificing at least some internal validity, why would you even want to do that? What would be the point of that in the real world? Well, I've already started to explain that, so I'll get into it when we get there. I will interrogate quasi-experimental designs by asking about the other types of validity. What about construct validity, external validity, statistical validity? Do those have the same effect on a quasi-experimental design that they do on an experimental design? And then the last portion of this chapter is looking at something very specific. When we talk about all of these sort of studies and correlations and experiments that we do, we're always talking about a large N effect. In fact, when I went over the discussion section lecture yesterday, one of the things I pointed out, if you were to talk about potential shortcomings or flaws in your experiment, one of the biggest ones that my students have when they actually do it is small n, right? And when you only have 10 people per group or something like that, we want a nice large N experiment. But what about very specific, very precise experiments that only involve a few people? What we call a small N experiment. Can it be computed statistically the same way that we compute large N? And the answer is no. So sometimes we're just testing one or a couple people at a time, and we still want to know that we have an effect with these people. So how do we treat the statistics, and what types of designs can we use for this? So I'm going to describe 3 small n designs called stable baseline, multiple baseline, and reversal designs. And I'll explain how each of them tries to address internal validity in its own way. And then I will give examples of questions you might ask about a small n design to look at the 4 validities: internal, external, construct, and statistical. And then, are there any trade-offs? What are the trade-offs of using a small n design versus a large group? We'll talk about that, because sometimes it might be better to use one than the other, even though when we think about, all things being equal, more people is better, power is better, all of this. But what type of design and what we actually study with a small n might be useful. So 2 portions to the chapter, which I should be able to conquer in one lecture, hopefully. And if not, I'll break it up. We'll see how the time goes. So quasi-experiments. Quasi meaning partial experiments, or kind of true experiments. I'm going to give you 2 examples of a between group quasi-experiment and 2 examples of a repeated measures, or what we would call a within subjects type of experiment. Then we'll talk about internal validity, balancing priorities, and then asking the question, are these experiments, since there's internal validity issues, are they the same? Can we even compare them to real experiments? What is it like in the real world? Would we have any reason to use these? So let's take this journey and find out. So quasi-experiments, again, can be both between or independent groups, right? Between groups is what we call it in the real world. The book calls it independent groups, because you're only in one or the other. And we have repeated measures where everybody does everything. And both of them can be quasi-experimental. The 4 types of experiment designs: 2 for between groups, non-equivalent control group, which is a post-test only, and a non-equivalent control group, pre-test, post-test. So this is very similar to chapter 10, when we talked about the 2 different ways to conduct a between groups design, right? We're not talking factorial or anything like that. We're going back to simple 2 groups. And they're called non-equivalent control. And the reason they're called non-equivalent control is because you can't ensure that everybody is the same, right? So in a quasi-experiment, the definition of quasi means that you cannot randomly assign them. Why is that? And would we ever use that in the real world? Well, the reason for that is the group comparisons that you're making are on variables like gender that you can't separate out. If you're male, you're male. If you're female, you're female. And other than some gender-related labeling, that's not going to change for majority of people. If you have short hair versus long hair, that can change over time, but at the time of the experiment, you either have short hair or long hair, and you can only be in one group or the other. So you cannot be randomly assigned into 2 groups. I'm going to give you a couple of examples of this from the lecture and the book. And, we will move on from there. For repeated measures, remember, repeated measures is another way of saying within subjects. Usually we talk about repeated measures as doing the same thing at different time points. So if I were to give you a depression test at one point, and then a month later give you that same test to measure if there's been any changes in your level of depression, and then again, another month later, right? So it's not just a pre-test, post-test, it's the same people at different time points or things like that. So we'll talk about 2 different types of experiments that are within subjects or repeated measures. Remember, those 2 phrases can be interchangeable. So interrupted time series design, and again, we talk about a non-equivalent groups interrupted time series design. So we'll go over a couple of examples of those. For the quiz, and of course for the exam, I'm not going into itty bitty details, so think about the types of assignment, the types of studies, these four. When we get to small n, look at the type of studies, understand what a quasi-experimental means, and things like that as you're preparing. So with a quasi-experiment, you're using both the design and the results, as we talk about, to evaluate the validity of a causal statement. So we're still looking for cause and effect. We're still looking to see if A causes B, and only A. We're still fighting to keep internal validity really high because this is still an experimental study. It's still a causal claim. But what about the other ones, right? The dirty dozen: design confounds, order effects, selection, maturation, history, attrition, regression, instrumentation, testing, observer bias, experimental demand, and placebos. We're still trying to evaluate our claims for these. It's just that in the real world, especially, sometimes there are things that you cannot randomly assign for ethical reasons or just for general reasons. And I'm going to give you some examples. So this example, the Head Start study, is actually from the 2nd edition and not the 3rd edition. I believe in your 3rd edition book, they talk about, and I'll talk about it a little bit, people's attitudes when passing by a church, but we'll get to that. So what do we mean by quasi-experiments? Well, again, quasi-experiments are experiments that you cannot randomly assign people into one group or the other because they either are or they are not. In the Head Start study, researchers wanted to look and see if regular preschool children who their parents, pay for them to go to preschool would have an advantage against lower income families who could not afford preschool. And the government started what they called the Head Start program. It's a preschool program for underprivileged, lower income families. And they wanted to see if the Head Start study was kept people at a disadvantage because they didn't have the resources that preschools had and things like that. So in order to be able to compare the two programs, regular preschools versus Head Start study, you had to use a non-equivalent group, which means that you can only have one group that are children that went to preschool that was paid for and things like that, and the other group would be children that were in the Head Start program. So you could not randomly assign them in this case. A lot of times they had already been in preschool and you're trying to track their progress maybe through high school even. What about the psychological effects of cosmetic surgery? Well, in this case, as we'll talk about, there were two groups of women who wanted to and got consultations for plastic surgery. But they wanted to do a check before and after the surgery. And of course, only some of them actually got the surgery. Some people go get a consultation to make themselves feel better, maybe found out their insurance couldn't afford it, or just decided it's not a necessary surgery, so maybe they don't like the idea of going under a knife for a non-life-threatening injury. Either way, that gives you two non-equivalent groups. You have women who did get plastic surgery and women who did not get plastic surgery. And again, you can't randomly assign them. So that makes it a quasi-experimental group. So both of these use a non-equivalent control group design. With the Head Start study, we're going to talk about a post-test only. With the cosmetic surgery, it's a pre-test, post-test. And I will point out exactly why. So here's the Head Start study. Again, looking at the graph, we should hopefully be a lot better at graphs now than we were at the beginning of the semester. We have two groups. We have two levels of the independent variable. On the x-axis on the bottom, students who had been in the Head Start program, and we had students who were not Head Start students that were in regular preschool. And of course, we have achievement test scores. So as you see, the non-Head Start students were fared slightly better in achievement tests, but maybe not a lot. I don't know, just by looking at this graph, if we can tell there's any statistical significance or not. I would tend to think probably not, but I don't know the scale of their achievement. But regardless, we do see that the non-Head Start students did get higher grades or higher test scores than those in the Head Start group. One of the things that you may notice down below in the graph under the blue column, it says matched non-Head Start students. So although a quasi-experimental design is non-equivalent, you can't separate people out. What we can do for selection effects, one of the things we talked about in chapter 10 and chapter 11, is that we can use a matched groups design. So what you'd want to do is essentially look at the age demographic, right, and match as many of those to the Head Start students as possible. Maybe you can do it by IQ, maybe you can do it by aptitude for whatever they can do in preschool. Either way, we would try to use a matched design to be as close as possible, even though we can't randomly assign. So that's another reason you'd use a match design, is if you don't have equivalent groups, if you have to be one or the other. At least you can match them up in as many variables as possible. Looking at the psychological effects of cosmetic surgery. In this case, there was a number of women, all of whom went at least for a consultation to the plastic surgeon or cosmetic surgeon initially. So we could have both of them or everybody come in, and we would have a non-equivalent control group again, or non-equivalent group design, because some people did it, whether they had the means to do it, whether they, for whatever reason, half the people did it and had the surgery, the other half did not. And what you can see is, what we have here is a pre-test post-test with multiple post-tests. So we have at baseline, we have 3 months later, 6 months later, and 1 year later. So what they measured was self-esteem. If you're going to the doctor or plastic surgeon to get a consult about getting plastic surgery, then your self-esteem already is probably low, right? So on the self-esteem chart, 0 to 25, what they wanted to see, looking at baseline, both the surgery and comparison group were the same. So we have, pretty equivalent groups in terms of their self-esteem scores. But it's quasi-experimental because you either had the surgery or you didn't. And looking over this, what we see is that those that got the surgery over 3, 6 months, a year later, slightly increased from where they were. They never went down. They went up maybe a little bit, not a lot, but kind of stayed at a higher self-esteem. Whereas those that didn't get the surgery took the biggest self-esteem hit in the first 3 months after. So maybe they were also taking a hit because they didn't go through with the surgery for whatever reason. And then, between 3 months, 6 months, and a year, it kind of stayed relatively the same, maybe slightly dwindled a little, not really much to make a difference, but you can see that comparison there. Whereas those who had the surgery stayed relatively the same or even increased a little bit over a year. Those that did not get it had a big initial dip in the first 3 months and then kind of leveled out. So those are the two types of, again, if we're looking at we have the non-equivalent control group post-test only, where you're looking at test scores for the Stanford achievement scores, and then the pre-test post-test. And of course, this one had about 3 post-tests, but it's the same idea because you either had it or you didn't. So the question I would ask you guys in class then would have been, if this has 4 measures, baseline and then 3 post-tests, why would this not be considered a repeated measures design? And hopefully you guys have the answer in your head, but I will reveal the answer to be the fact that you're either in one group or the other. You're not in both. Remember that in a repeated measures design, or in a within subjects, within groups design, everybody does everything, right? So just to remind you of that, that's why this one is a independent or between groups and not considered a within subject or repeated measures design. So what about repeated measures designs? Well, we have two. One is based on food breaks and decisions on who gets parole. And the other one is actually taking a amount of data from the past and looking and comparing television access and crime rates. So let's go back really quick. I apologize. And we have two different types of repeated measures or within subjects designs. We have the interrupted time series design, which is the first one with food breaks and parole hearings. And we have the non-equivalent groups interrupted time series design. And that's the one we're going to talk about with crimes and TVs. So let's head back in this direction. Food breaks and parole decisions. In this case, what we see before we read the caption is ordinal position. So you have the first case of the day on the left, and you see the lines that are being connected for each different case. And then you see a dotted line, which is basically a lunch break. And then you see more cases in green where the peaks are. And then you see a second dotted line, which would be like an afternoon coffee break, that 2:30 feeling, right? And then you see it go towards the last case of the day. So in this case, why is it a repeated measures design? Because they are seeing different cases, parole cases, but it's the same parole board, the same people that are seeing case after case after case. So this is a repeated measures of seeing of everybody that are judges, seeing all of the parole cases that are up for a parole decision. So you see the proportion of favorable decisions based on the order in which the cases are heard. So what we see here, first case of the day, is about a 65 to 67% chance of getting parole. The second case of the day is actually even better. If we were to look at that point, that's about a 0.75. That seems to be about the highest one of the day. And then it gets a little lower. Third case looks to be about a 60% chance. Then the next case about 30%. And as we get closer to lunch, those numbers dwindle lower and lower and lower. We could make our case for this, right? That maybe you're getting a little hungry, your energy levels are a little low, and you're just tired of hearing by the seventh case of the day or fifth case of the day, whatever it is. And you're less likely, a little more grumpy, hangry, a little less likely to give the person parole. Then they have a lunch, they refuel their systems, and look at that. It jumps up right after lunch, that first case, to about 70% again, 67% again, right? It's very close to the first case of the day because it's the first case after they've refueled their system. And then we get another similar trend, 3, 4, 5 cases, and as it progresses and their energy reserves get lower again, we get, and their caffeine levels get lower again, right? We get less and less chance, less and less likelihood of favorable parole decisions. Then we have that coffee break, and maybe they refuel. That's that 2:30 feeling, maybe, and they have their 5-hour energy or whatever, their coffee, and then boom, it's right back up to almost 0.7 again, right? 2.67% chance maybe. And then that dwindles pretty quickly by the end. And if you're one of the last cases of the day, well, then luck is not on your side, because those people only get paroled maybe about 10 to 20% of the time, as you can tell, right? So this is a repeated measures interrupted time series design. As you see the different times of the day, and it's interrupted where the dotted lines are by lunch break, interrupted by coffee break, and then it resumes. So this is a version. And again, everybody is criminals looking for parole, so it's not like you're randomly able to assign people into being a parole or not, or this is their situation, right? So this is a repeated measures, and it's a non-equivalent design because everybody's there for the same reason. If you were a convict, if you're in jail and you're up for parole, that's who you are. We can't select you randomly. For TD access and crime rates, this is looking back in the years of 1951 and 1955 and noticing a trend. Two things that were never studied together, but looking at past archival data or past history, um, we are looking at in yellow cities that got TVs around 1955 and looking at the line itself being the crime rate in that city after TVs were introduced, and cities that got TV around 1951. So we have a big difference there. And you can see between those two lines that there's a big difference in yellow and green. Before and after those two lines, it's pretty much equal. But there is that one big difference is between 51 and 55. So what we're looking at here, taking old data, is looking at the cities that got TVs and comparing their crime rates. And of course, you could go back and make the argument that those cities that got TVs, when other cities didn't have them and other people didn't have them, might have had a greater crime rate because people were stealing TVs, or maybe people were at home watching TV, so it was easier to go out and steal stuff. Could that be the only reason? No, but this is one explanation that we could come up with, right? And the data kind of fits here. So we are using a repeated measures design, right? In this case, to look at TV access and crime rates. We can see that the cities in 1951, crime rate went up, whereas it stayed lower, larceny rate, in the cities in yellow that did not have a TV at that time. And then at about 1955, when TVs were around for that city, the crime rate seems to have caught up to, in yellow, seems to have caught up to green. And quickly thereafter, the crime rates rose about the same amount for both cities, right? So we can see that we treat them a lot like regular quasi-experiments are treated a lot like regular experimental designs, except for the fact that we cannot randomly assign. But a lot of basically everything else is the same. So we try to treat them the same. The problem, of course, is that what we're losing is what's most important in this type of design, right? The causal claims, as we've been talking about in the last 4 chapters now, 3.5, is that internal validity is the priority in these experiments. In fact, in correlations, in surveys and polls, right, and the other types of claims, we don't even have, right? We don't even need internal validity. So it's essential in these experimental designs and these causal claims. So how do we check for internal validity problems? Well, the same way we would do it in a regular full true experiments, full causal claims. We're still looking for design confounds. We're still looking for selection effects. However, we know that we can't randomly assign. So the way to sort of get around that is to use a match design to the best of our ability. In archival data like this, you can't really do that. But what could we look for in a design like this? Well, what about confounds? Are there any other things that could have happened between 1951 and 1955 that we didn't account for? Because using archival data, for one thing, you can't control anything because it's already been done, right? So confounds, were there any other things that could have also caused greater rates of larceny? People like to steal a lot of cars. So maybe those cities that got TVs, and if people could afford TVs in those cities, then maybe they were also getting more and more expensive cars, right? So that could be a confound, that people were stealing more because there were, cooler looking, more expensive cars around, and things like that. Or maybe there were more banks and banks got robbed. So it might not just be TVs, right? Maturation threat. Could there be something between 1951 and 1955 that caused people to steal more or steal less? Maybe the ages of a lot of people. I don't know. So I wouldn't really I wouldn't say a maturation threat is probably a likely candidate, but here's one that really probably would be. We're looking at historical data, so we should look at history threats. Was there racial issues? Was there other issues in the 1950s in that time that might have accounted for people stealing stuff? Was there a recession where people couldn't afford? Was there a lot of unemployment where people didn't have jobs in these different cities, right? There could be the most likely internal validity threat, in my opinion, on historical data would be history, right? It's not going to be attrition. It's not going to be regression to a mean or anything like that. So we're doing our due diligence and just trying to find out, is this study susceptible to some of these internal validity threats, to the dirty dozen? We know that we're not worried about experimenter bias because we're looking at archival data. We're not worried about placebo effects. We're not worried about selection or anything like that in this case, right? We're not worried about attrition, people dropping out of a study, because we're just looking at overall sort of grand data. So when we are looking at internal validity to quasi-experiments, if we go back to the Head Start study, one of the things that we will talk about is selection effects. That's the biggest one in all quasi-experiments. And so how do we do that? How do we mitigate that? Again, you can't solve that problem because we can't have true random assignment, but what we can do is use a matched study. So in this case, looking at the students in Head Start, we could match their scores as best we can to scores of people in regular preschool programs. So you can see down there for pre-test and post-test. So that's one of the things we can do is make that post-test only design a pre-test post-test so that we can match scores of students, match their scores in achievement in preschool, and then track those scores through the K through 12 system maybe. So you can see on the left in orange that we match Head Start students group, and we match non-Head Start students group. The problem with a match design in this case is if there is truly a discrepancy between just the students, right? Just the children that are taking it. There may be a problem here. So one of the biggest internal validity threats here could be regression to the mean, because if you're matching up students, you might be getting high achieving Head Start students being matched up with lower achieving non-Head Start students. And that could be, the differences could be due to those regressions. If you're getting really high scores from Head Start students, that might be, right, that they just might have excelled in one area more than the others, and they might regress back to the mean. For the students in the non-Head Start program in regular preschools, they may be extremely low group means that are matched up with the others, and so they may score higher in subsequent tests, or they may have regressed up, as you can see. So that's another potential internal validity threat here in the Head Start study program. Now, I told you guys that in your book, in the newer version, that there was a study, instead of the Head Start study, it's a study looking at people who walk by churches and things like that, and their attitudes towards other groups. Because there seems to be two different types of people, those that are religious and tend to judge others harshly, and those that are not religious and may judge those that are religious a little more harshly, right? I mean, I could go into the reasoning, but I think you guys already know. So what about other internal validity threats in this cosmetic surgery groups? Again, we could have a regression to the mean, right? So there is the possibility that some people were feeling extra self-conscious or depressed, and their outlet was to go just get a consult, just to talk to somebody about it, and then realize, no, this isn't for me. So one of the reasons why they didn't get surgery, so they'd be in the comparison group, would tend to be that maybe they were at an extreme. So you might get a little bit of regression to the mean here, although we wouldn't talk about that one as much. What are the types of threats that we see here on the left? Attrition. Of course, attrition. That's a big one, right? Especially if they didn't go through with the surgery. Why would they want to keep taking this test? 3 months later, maybe, yes. And then 6 months, and then a year later? No, I just went for a consult, and you're not giving me enough compensation for this. I'm not gonna ask your questions a year later. I'm over it. I went, I got a consult, my self-esteem took a hit a little bit. I don't want to do this anymore. Of course, we could have testing and instrumentation threats. So looking at this, you're getting multiple comparisons, right? In 1 year, you have 4 times. So simply by being asked this question, you could get the increase in self-esteem, especially those that got the surgery. Oh yes, I look great. Oh, I feel great. Oh yes. And those that didn't, right? You may have a testing threat. Instrumentation, maybe they are, and a lot of times on this, it's a sort of a self-report when they go through these tests. So their self-esteem tests that simply they're kind of over it after 6 months or a year, and they're just answering questions and bubbling things in. Um, Maybe they're yay saying or things like that they're not really taking it seriously. In that case, we can call that an instrumentation threat, because although the test is the same, the way that they feel about it, their calibration, quote unquote, of it, they're just kind of apathetic and like, whatever, I'll just answer whatever questions and get out of here. Of course, we have observer bias, demand characteristics, and placebo effects, right? So those in the study would, if they have, right, if the researcher has a theory that participants should be feeling more attractive, they may see the ratings as more attractive or may give that away. Demand characteristics, of course, the people who did not get surgery would not expect to feel as pretty or have as much self-esteem or general attractiveness as somebody who didn't get plastic surgery. So it could be the way that the participants respond based on what they think the observers or the researchers want to hear. And a huge one in this case, right, is placebo effects. So look at the boxes on the right, the green and orange boxes. Perhaps the participants that are increasing over time reported feeling more attractive simply because they just expected to look better since they had the surgery, right? Barring any complications from the surgery. Well, I look better, I expect to look better, so my self-esteem is going to be high. And those that didn't go through the surgery, perhaps they reported feeling less attractive because they knew they had not had any procedures that were designed to make them look more aesthetically pleasing, shall we say. So that could be, placebo effects could be a big reason for this. What could we do? Remember back to chapter 10 or back to chapter 11, where we talked about adding a third group, maybe a true control group that never even considered getting surgery. That could be a way to sort of mitigate this. But as you can see, what we're doing with these quasi-experimental designs is we are looking at their internal validity threats exactly the same way that we would for a real design. The only difference is we all automatically lose at least a little bit of internal validity because we can't truly have a equivalent group. So how do we balance our priorities? And are quasi-experiments still worth it? Well, I think I've been making my case that they are. In the real world, we have more chances of getting quasi-experimental designs than true experimental designs in a lot of different ways, because we are comparing two different groups of people who can only be in one group and not the other, right? So in the real world, if we're looking at the difference in lung capacity and things like that of people who smoke versus people who don't smoke, you can't, right? It's unethical, for one thing, as we see ethics here in the third bullet point, to try to get people to start smoking just to see if you can get them to stop smoking or to compare them, right? So let's look at priorities and quasi-experiments. Let's look at what happens in the real world. Let's look at external validity, which, if you recall from chapter 10, external validity most of the time, and when we get into chapter 14 next week, we'll really talk about this, that external validity is the lowest priority in a causal claim. In the quasi-experimental world, it's the same thing, right? So let's look at external validity, construct, statistical validity, as well as ethics and real-world opportunities. So just to do a concept check here, In quasi-experiments, what validities do we gain? Again, we still have good construct validity. We should still have really good statistical validity. External validity has always been kind of a question mark in causal claims. It's not the priority. External validity, remember, is a priority in some of the earlier types of studies that we talked about. In this one, it really depends, right? And in the next chapter, in chapter 14, we're going to talk about why that is. At least when we are testing a theory, we don't need to know if it's generalizable. The main priority is knowing that A actually causes B and that our theory is actually correct. So external validity does have a place in causal claims, but a lot of times it's based on once we've already established the initial theory is that it's true. So we're trying to gain as much internal validity as possible, but we lose a little bit, of course, because we can't truly randomly assign. And match groups, we can match, but you're still not getting full internal validity. We are not sacrificing construct or statistical because those are mainstays. Those have to stay really good. If you don't have good construct validity, as we have established in this class, then we're in trouble because that means we haven't measured or defined our variables in the best way possible. Statistical validity, to know that we're getting actual results, we need to know that the measures are good, that we have enough people and all of that stuff, right? So we're definitely not sacrificing there either. Of course, you can't help but at least a little bit sacrifice internal validity, even though you're making sure you don't lose a lot of internal validity. So in the real world, we have smoking versus non-smoking. We have surgery versus non-surgery. We have Head Start program versus regular program. These things are not able to be randomly assigned. So if we can't randomly assign and we are giving up some of the most important validity, internal validity, are we just looking at glorified correlations? Well, let's make the argument. Both of them may use designs where you're only measuring one group, right? Where you're only doing one thing and measuring it. Neither correlations or quasi-experiments use random assignment because you can't use random assignment in a quasi-experimental design. And neither use manipulated variables, right? So remember that in a correlation, we have two measured variables. Quasi-experiments may use techniques like what we call active selection. I'm not going to go over that here. You can read about that in the chapter if you want to. So are quasi-experiments just correlational studies? I really, really hope that you know the answer is no to this. We still have internal validity threats. Correlations, right? Correlation does not imply causation. Correlation cannot talk about cause. We can still look at causes. We can still look at internal validity, which doesn't matter in correlations. We are still very much investigating internal validity. So the answer, of course, and it should be really obvious, is that quasi-experiments are still better in causal claims, and they're not just correlational studies. Although they may not be truly manipulated variables, meaning that you can't randomly assign into one group or the other, we are doing our best job as researchers in trying to match or get as close to an equivalent group as possible, even though you can't truly do that in a quasi-experimental design. So that brings us to the second portion of the chapter, and I think we've only been going for half an hour here, so it's fairly easy for me to finish this all in one shot, and I think that might be easier for you guys too.